Precalc, it's Hofbauer here. I hope this is recording okay. I hope you all are doing okay. I think this lesson is at the end of week 2, so I hope you're getting the hang of this e-learning blended model business. So I'm going to get started. This is the first lesson out of our textbook. So tonight's assignment is bookwork. And hopefully you'll all be able to figure out how to get onto the book and do that. Today we're going to talk about functions. It starts out with subsets of real numbers, and we have already talked about these when we did the unit on complex numbers. So I'm going to go through this kind of quickly. Real numbers is this whole broad category here that includes everything except, you could branch off over here and put our complex and imaginary friends over here, all the I's, okay? Everything else is real. We have, there we go. We start out with the numbers like Mama taught you to count, 1, 2, 3. Those are called natural numbers. When you add in 0, it's called whole numbers, but that's all, just 0 plus the natural numbers. When you start talking about negative and positive numbers, it's integers as long as they're all whole numbers, so to speak, except they could be negative. Rational numbers get real funky because it's everything we talked about so far plus anything that could be written as a fraction or a decimal, whether it repeats or ends. So that's a lot of things. A lot of numbers in there. And then we get to the irrational. That's things like square root of 2, e, pi, that's supposed to be a pi symbol right there, etc. Okay? So here's the way your book writes it. They use some funky little letters here. They do use a double-lined R for real numbers, and most of the rest of these I can't keep straight. All right, one way to describe a set of numbers when we want to restrict it and only talk about part of the set of all those numbers is to use interval notation, okay? You should have had this possibly starting in Algebra 1, definitely in Algebra 2. Interval notation is when you use okay, I think I still have sound. It is when you use things like to say x is greater than 18, you say it goes from 18 up to infinity to the right. So we say we want to not include 18, but everything going up towards infinity. Do you kind of remember that? Okay. Whenever you have an infinity, it is always a parenthesis. Whenever you're not including the number, it's a parenthesis. But if you want to include the endpoint, then we use what I call brackets, these little square guys. Okay? And it's important that you remember to always state it from the least to the greatest. So let me give you one quick example. If I wanted to say everything to the left of -3 up to -3 and everything from 5 and to the right, you would need to write negative infinity up to 3 with a bracket because it's included, together with all the numbers from 5 up to infinity. Okay, we're going to practice this a little bit, and there is also a place in your book that explains more. This is in the book, and it talks about how to write those. Okay, so here's our quick examples. X is less than or equal to -2. If we did a number line, we would say going to the left. So therefore, we have to start from the least value, which would be negative infinity, and say it goes up to -2, and it said or equal to, so we're going to have the square bracket, parenthesis always goes with an infinity. This one says -8.8 and greater. Greater than means it's going this way to the right. It does not include the negative, it doesn't have an or equal to, so we would have a parenthesis, whoops, I can't write eights and infinities. Okay, 8.8 to infinity. That was complicated. All right. This one says just simply everything between 5 and 15, and it doesn't include either end. So it would look like this on a number line, and it would really just look like an ordered pair. Kind of confusing. And this one says everything below negative 11. Okay, going this way. And above, including 1, going this way. So if this was our number line, here's where we're shaded. We have to say, starting left to right, or least to greatest, we start from negative infinity and go to negative 11, not including. And then we include 1. The U means union or together with. Everything starting at negative 1. Oops, it's positive 1. I don't know why I put it. Looks like an E anyway. Together with 1 to infinity. There we go. All right. Then we're going to talk about functions and relations. A relation is any rule that relates or pairs the elements in some set A with the elements in set B. Set A contains the inputs or the domains, and set B contains the outputs or the range. A function, f, from set A to set B is a relationship that assigns each element in X to exactly one element in Y, okay? Your X's can't repeat. They can't be paired with 2 different Y's. So, generally the domain is the X values and the range are the Y values. And the Y value depends on what you choose for the X. So X is the independent variable and the Y is the dependent variable. All right, so we got to remember this, important for today. Domain, range. D goes with X, range, Y. Alphabetical order, D before R, X before Y, however you want to remember that. All right, so quick picture here. This is a function, even though one of the Y values is used more than once, it is still a function because the X's do not repeat. This is a function because no vertical line will hit it more than once. Now, this is a little sidetrack here to the book. You will go into create an account following the Google Classroom notes about how to do that. When you get there, you will only have the student edition, and then you're going to click on ebook up here, okay? But I'm going to go back because this is what we wanted to watch, was this silly little video. Where is it? All right, let me try again. Okay, maybe I'm not going to find it today. It was just a little video I wanted to show you. About what I don't know what page it's on, I'm just guessing here. Here, is it this? Animation, there we go. All right, this is it. It's not exciting, but it's kind of a review for some of you. Where's the sound? Well, this video is not going well, is it?
Use the vertical line test. The vertical
In here it was crossing twice. All right, so that wasn't very exciting, but in case you can't remember what the vertical line test does, there we go. All right, so is this a function? The x's do not repeat, so yes. Is this a function? Vertical line test fails, so no. Now, we got to think with this one. To determine whether it's a function, we can't really graph this, but if we think about this, if I put a 2 in here or a -2 because it's squared, okay, I'm going to get two different y values out that are going to be the same per this x value. So if I put a 2 in here, I'd have 4. If I subtracted that over here, I'd 1. If I divided, I have -1/2. So -1/2 is the x value for both 2 or -2. So whenever the y is squared, that's going to be a good old no. All right, see. Oh, they showed it here. They solved, they subtracted, added the 2x over to the other side, and then they square rooted, and remember you get a plus or minus. So therefore there are two values, okay? A plus and a minus for every x, or for two different x's would give you the same y. Anyway, moving on. To tell if a relation, oh, we got a vertical line test thing going on here. Okay, so A says draw a graph that is a function. We could draw a line, we could draw a parabola, etc. B says draw a graph that's not a function. I'm going to draw one that goes this way because it would fail the vertical line test. That would be not a function. All right. Then we get into function notation. I hope everybody remembers this notation, but you are putting, it says f of x equals, so f of -4 means when x equals -4, find the value of the function. So it would be 4 times -4 to the third plus 6 times -4 plus 3 times -4. And we can grab our calculator for that one. See if I can manage to get this off on the side so we can see it. We have 4 times parenthesis -4 parenthesis to the third, arrow to the right, plus 6 times -4, and I'll go ahead and put parentheses, I could just do times there, plus, oh, that was supposed to be squared. Ooh, and I have not a parenthesis, okay. Squared, I'm looking up here, it was supposed to be squared, I forgot to write it here, I'll fix that in a second. And then plus 3 times -4. All right, and we get an answer of -172. This one had a squared, and it's very important the negative is inside the parenthesis and the squared's on the outside on that one. We got -172. This was 4 times -64 plus 16 times 6 is 96. Got to square first. Minus 12. That's where that all came around. All right. Back over here, we have 2a is our x. So we need to put that in here. So we're changing variables. We're replacing x with both a 2 and an a. All right, we got to be real careful. This is, remember, to the third, so it's a 2a times a 2a times a 2a. So it's not just 2a to the third, it's actually 8a to the third. And then we still got to multiply it by 4, which is just going to make it 32a to the third. This one, 6 gets multiplied by, this is 2a times 2a, which would be 4a squared. So that's a 24a squared. And back here, 3 times 2a is just 6a. And we cannot combine any of those like terms, so this is our answer. Okay, so I hope you remember function notation. I have a few more examples of that in a second. And then we have evaluating piecewise functions. When you evaluate piecewise, you have to pick which of these three rules this value goes into. It says for 1. Well, 1 is less than 4, less than or equal to 4, so we put it in here and we get square root of 1 plus 1. Okay, guys, please tell me you know the square root of 1 is just 1. 1 times 1 is 1, so the square root of 1 is 1, plus 1 is 2. The next one, you're to put a 3 in. Well, 3 is still less than or equal to 4, so we get square root of 3 plus 1, which doesn't simplify. I think if we did it on the calculator, we might get approximately 2.71. I can't remember, but anyway, you could approximate it, but it's just a decimal. You can leave it like this. All right, put a 6 in. Well, 6 falls between 4 and 6, so that goes into this rule, and we do 3 times 6 is 18. And then the last one is a 10, and 10 is not included in this rule. It is included here because of this or equal to, so it says if 10 is greater than or equal to 10, so we're going to use this rule. So we have to do 2 times 10 squared minus 15. This would be 100 times 2 minus 15, or 185. All right. Find the value. I'm going to skip this one and go back and do it on the notes if you want to check, but you're just putting a -1 in. But I want to show you this one because somebody's going to do some crazy mistakes here. You got to put an x plus 8 in where there was an x. So you're replacing the plain x with an x plus 8, so we have to square it here. Minus 8 times that quantity, plus 1. Now remember, there is no such thing as distributing a squared. Remember my Batman and Robin meme? You have to write this out. Oops. And FOIL it together. X times x is x squared. Outside, x times 8. Inside x times 8, that was an x. Multiplying 8 times 8. Then we can distribute over here. Minus 8x minus 64. And then there was this plus 1 on the back. And we can simplify. Let's see, we have an x squared. 8x and 8x minus 8x. Oop, that'll get rid of one of those. So we have an 8x. And 64 minus 64, and a plus 1. That's all that's left. Okay? This is what it means, but because we're in Precalc, you need to simplify it. Okay? Can we do this one real quick? Evaluate again. If we're putting a 3 in, it goes in this one because of the or equal to. This says 3 is less than or equal to 8, which is less, I'm sorry, x, which is less than 8. So everything from 3 almost up to 8, but not including 8, is this rule. So we'd have 2 times 3 plus 10 would be 16. And 8.5 is a little over 8, so we're using this rule. Well, this rule says you just get 42. No matter what you put in above 8, you just get 42. All right, now we're going to talk about domain and range, and if this is a function. First of all, this passes the vertical line test, so it is a function. And then we're going to talk about its domain and range. The domain and range are the x and y intervals. So domain is left to right across the x values. So what is the furthest left? This goes on the x, and the furthest right. Please notice it does not stop going to the right because of this arrow. So the furthest left it started was -4, but it had an open circle. So we put parenthesis -4, and then it goes off to the right forever, so we say infinity. Now, range is y values, and we have to go least to greatest, so we have to start at the bottom and go to the top. Well, the bottommost y value we have is here at -1, and then this graph goes up, 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 and it keeps going up. So the lowest it was -1, and again it was an open circle, so we have -1 and up would be to infinity. All right, so remember, domain is left to right. Start on the left and go to the right. And range is bottom to top. Start at the bottom and go to the top. But again, this is y values, so you're using numbers off the y-axis. Domain is x values, using number off the x-axis. All right, let's see if I can move this up. First of all, is this a function? Any vertical lines will never cross it more than once, so yes, it's a function. Now, it goes to the left and up forever, and it goes to the right and up forever. So, what color did I use? Okay, domain was red. All right, so the domain, left to right, it is going forever to the left and forever to the right. It's going off this way and off this way. So we say -infinity to infinity. But the range is not. When we start at the bottom, it does have a lowest value here at 0. And it appears to hit 0. Unless you see a big old open circle, just assume it's hitting that value and includes it, okay? So it starts at 0 and it goes up forever, so it doesn't have a top. Bottom to top. Oh, I should have done that in green. I was trying to stick with a color scheme here. All right, I'll do better this time. So is this a function? Well, I can start drawing vertical lines and they will never cross it more than once. Ooh, I don't know. Right over here, it's a little iffy. That looks like a vertical line might cross it once. So I don't know if this is a function. I'm really not too concerned about that. I won't give you one like that on a test or quiz. But this is a great example to talk about domain and range. All right, domain, remember, is left to right x values. Well, this has a dot, not an arrow. So the furthest left it goes is -5. And then it doesn't matter what's happening in between as long as it's hitting all these values somewhere. And then the furthest right it goes appears to be here at +4. All right, but the dots don't matter, the ends don't matter when we're doing range because it goes further down than those dots. The furthest down it goes is -3, and we're gonna say it hits it. And it goes up, the highest it ever gets is 3 because there's no arrows. So we would say -3 to 3 are the y values or the range values. All right, I have one more. This is definitely not a function because it fails the vertical line test. The domain from left to right would be, it goes as far left as -3, but it is an open circle, and it goes as far right as +3, and it doesn't show an open circle, so I'm going to assume it hits it. So that was left to right along the x-axis, okay? The range is bottom to top along the y-axis. The lowest y value was at -2, and it had an open circle. And the highest y value is at +3, and that has an open circle as well. All right, I have a few more examples at the end of the slides that I will do, so check those out in the notes. Okay. Then we have one more thing to learn today. It's called about restricted domain. When you are given a function in equation form or expression form, you are to find the domain. It is all real numbers, okay? It's always all real numbers, unless there is a restriction. The domain of a function is restricted when there is a radical or if there's a denominator, okay? The denominator cannot be equal to 0. So whatever's in the denominator, if you have an expression over another expression, this expression cannot equal 0. That's it. Otherwise, the domain is all real numbers except whatever the denominator would be 0. If you have a radical, whatever is underneath the radical here has to be positive or equal to 0. So you say greater than or equal to 0. And then you solve for what values would make it greater than or equal to 0. Because you can't take a square root of a negative number. Now, you can take, if it's a cube root, you can take a cube root. And that's why it says even radicand. If this was a degree 2 or a degree 4, then we would have to deal with this. If it was a degree 3, it would be all real numbers. Okay, because like the cube root of -8 is -2. -2 times -2 times -2 is -8. So you can do negatives from degree 3 radicand. All right, anything else and you have all real numbers. So this particular one has a denominator, and the denominator can never equal 0. So if we factor this, we would say it can't equal 0, so therefore we factor it, just take out an x, and we say what values would make that equal to 0? Well, this piece would be 0, and this piece back here would be 6. So the excluded values are 0 and 6 because they would make our denominator 0. Now, if we were going to write this in interval, I would just write all real numbers except x cannot equal 0 or 6, okay? This is the lazy man's way. But if we want to write everything on the whole number line except there's a hole at 0 and there's a hole at 6, we have to write this real strange. You say up to here and in between here with an open circle and then starting again. So it's from -infinity up to 0 and 0 to 6 and 6 to infinity. Notice we have no square brackets because 0 is not included, but like -0.99 and positive 0.00 are included. Only 0 is left out. All right, so that's a hard way to write that one. All right, so let's look at a couple more examples. Is there a denominator or a radical? Nope. So therefore this is all real numbers, or -infinity to infinity is the domain. And that's because there's no radical and no denominator. This one has a radical. Anybody remember what goes on? When it has a radical, whatever's underneath here has to be greater than or equal to 0 because we can't take radicals of negative numbers. Well, this has got negatives everywhere, but we say this quantity, whatever it is, has to be greater than or equal to 0. And then we go back to algebra 1 and we say, well, I'm going to add 2 to both sides. Whoops. Then I'm going to divide by -3. Does anybody remember what happens? When you divide by a radical or negative with an inequality, this number goes from being positive to negative, so it flips this inequality around because you've changed signs. So when you divide or multiply by a negative, you have to reverse the inequality. So the only numbers that will work in here are numbers less than -2/3. Let's think about that for just a second. If you put that in there, -3 times -2/3, it would be 6/3 or 2 minus 2 is 0. Okay, so it does check. If you put it in there, you get 0. If you put in anything less than that, you will get positive numbers. You just got to trust me on that one. So in interval notation, it says less than up to -2/3 and including, so we get a square bracket. All right, is this a function? The y is not squared, the x is. I hope most of you recognize this has an x squared, so it's going to graph as a parabola. We just finished that unit. So therefore, it is a function. And what are the domain and range? Oh my goodness. Well, we actually don't have to get out our graphing calculator here. I think we remember this. X minus 1 means the vertex is at 1. There's nothing on the back, so it would be at 1, 0. It's a positive 5, so it would open up and be narrow. So the domain left to right, guys, is X. We can put anything we want in there for X. All right. But the range, if you look at the graph, is only when you square something, it always becomes positive. So it's never going to be negative what comes out for the Y value. So it's 0 and up. And graphing that would have helped a lot. All right, domain restriction. I'm going to talk about the graph in a second, but this is a fraction. So whatever is down here cannot equal 0. So if we factor, we get x equals 5 or 3. And those are the things that are restricted. So it's all real numbers except x cannot equal 5 or 3. If we were doing that crazy interval notation, it would say everything up to 3, and then everything between 3 and 5. Remember, we've got to go least to greatest here, and everything from 5 and up. This is what the graph looks like, guys. That's why it doesn't work at 3 and it doesn't work at 5. There are what are called asymptotes there, or undefined places, because of this, because the denominator is 0. All right, and then the trick of all tricks. Whatever's underneath a radical, the rule is it has to be greater than or equal to 0. But they are trying to trick us because they put the radical in the denominator, and the denominator can never equal 0. So we have to take this little equal sign off. We have to say x minus 5 has to be greater than 0. Only positive numbers bigger than, if we add 5 over there, 5 will work here. If we put in 5, we get 0, and you can't divide by 0. But if we put in 5.1, we get 0.1, and you can square root 0.1, and you can divide by 0.1, so anything bigger than 5 works. So we have 5 to infinity. That's about as tricky as they get. All right, this one you just factor the denominator. I'm going to leave that, and I'll do it in a second. All right, I'll put those in the notes, but your assignment is to do a book page 9 and 10 in the textbook. If you're a remote learner, hopefully you picked up your textbook, but everybody has access through Google Classroom. Look under resources. It talks about how to get your book. And then do these problems. There's only 9 of them total. The last 2, kind of ignore their directions, please, and do the domain and range. And then be sure you check your work, because I put my lovely handwritten answer key in the classroom so that you can check your answers against mine. Let me know if I made a mistake. All right, guys. See you soon. Bye.